about mole concept, and this is very fundamental concept in chemistry, and this lesson is going to be very useful for the class 9, 10th and 11th 12th students. So we'll हम समझेंगे mole concept क्या है. So why do you have to have mole concept? So mole is a fundamental unit in chemistry used to count particles at, okay, like atoms, molecules, ions and electrons, because they are far too small to count individually. So atoms together can form a structure, and usually counting them is very difficult because we can't see it. So mole is a fundamental unit, and they are a single mole of an amount of a substance contains particles, and that particles number is 6.022 into 10 power 23 molecules. So we have a molecule, one mole has a this many particles in it. Okay, whether 1 mole of sodium metal ho, 1 mole of sodium chloride or 1 mole of sodium potassium chloride or 1 mole of sodium hydroxide. So each will have this many particles if it is 1 mole, and this number is called Avogadro number. At why we use moles? So atoms and molecules are extremely tiny, so they are very difficult to count. So mole gives us a practical way to relate microscopic particles to measurable laboratory quantities like grams. So measuring in moles gives you a very easy way of finding a amount of reactions which has happened. So you mix two reagents and it gives a product. So you can looking at the just by gram, it is very difficult to decipher how much conversion has happened. But if you look at by the mole, you will know 1 mole will react with 1 mole of something, will give you 1 mole of something, or maybe 2 moles of something, depending on the your balance mass equations. So regarding that, it is very helpful in that. So in the mole concept, we learn molarity and normality, and we will look at some of the mathematical problems to understand mole concept. Okay, so in fact, moles is related with mass of the substance and its molar mass. So moles is equal to mass over molar mass, where molar mass is 1 mole of mass will have whatever the mass it has, and moles is also related to the gases. So at STP, that is the standard temperature and 1 atmospheric pressure, it has 22.4 liter it will occupy. So for example, if you take 18 gram of water, how much mole it has? So if you look at the molar mass, it has 18 gram, right? That is per mole has 18 gram, and so 18 gram of, so in fact 18 gram of water will have 1 mole of water, and practically it will have this many same number of molecules, Avogadro number molecules it will have, that is 6.022 into 10^23 molecules. Now how do you define molarity? So molarity is another concept which is related to mole, and it has a very practical applications in the day-to-day life in the chemistry or day-to-day life in research. Okay, so how the how do you define molarity? So it is defined as number of moles in 1 liter of solution. So it is defined as number of moles which has dissolved in 1 liter of solution, that will give the molar strength. Mathematically it is represented by m, and is equal to number of moles over volume in liter. So that way we'll come to know the molarity. So if you dissolve 1 mole of sodium hydroxide in 1 liter of solution, its molarity will be 1. Normality is quite similar to molarity, but it has not related to number of moles, but it is related to number of equivalents, and that equivalence has different meaning. We'll discuss in the next slide. But mathematically, it is defined in a very similar fashion: number of equivalents over volume in liter. So it is given the normality definitions. So it is defined as number of equivalent in 1 liter of solutions. So what is equivalent? So equivalent is defined for different things, like for acid, for bases, for the redox reaction, or for the precipitation reaction. So in an equivalent depends on what the solute does in the reactions. So for example, in hydrochloric acid, there is a solute called H plus ions. So how many H plus ions an acid can donate in the hydrochloric acid solution? So it can donate, give 1 H plus ions. But if we look at the sulfuric acid, it can give 2H plus ion. So equivalencies for hydrochloric acid is 1. For the sulfuric acid, it could be 2. Similarly, if you look at the sodium hydroxide and calcium hydroxide, so sodium hydroxide has only one hydroxide ion produced by each molecule. So, and for the calcium hydroxide, for one each molecule of calcium hydroxide can give 2 hydroxyl ions. So, its number of equivalents can be 2 for calcium hydroxide. Or, for example, how many electron a species transfers in a redox reaction, that we will discuss in the next slide. So, that is also considered as a number of equivalents. So, redox reaction is nothing but oxidation and reduction reaction could be the redox reaction, and we'll see some examples and discuss thereafter. And how much charge is replaced in a precipitation reaction, this is another which is used for number of equivalence calculations. So look at the redox reactions and the species transfer electrons in a redox reaction. So how the species transfer, say ferrous oxides gets oxidized to ferric ion. How it gets oxidized? Because it loses one electron, so ferrous ion becomes ferric ion, okay, by losing one electron. So in the real life scenario, you have a ferrous hydroxide which will interact with or with react with oxygen and water molecules to give ferric hydroxide, and this way it loses one more electron and becomes 3 plus, from 2 plus to 3 plus. Similarly, potassium dichromate, which can accept electron and can reduce its charge on it. So from this potassium dichromate, which will have a higher charge, from plus 6 it become plus 3. So it will accept 3 electrons and it becomes Cr3 plus. Similarly in potassium, so if there is a gain of electron, it is called reduction reaction. So reduction, this is an example of reduction reaction where potassium dichromate becomes chromic acid or chromium 3 plus. Similarly, potassium permanganate become Mn2 plus. So here it becomes it accepts 5 electrons and become plus 2. So this is also acceptance of electrons and it's a reduction reaction, and this happens in acidic medium. So these are the examples of redox reaction. So equivalence will have 5 species in it. Okay, so 5 number will be considered for if we are calculating the equivalence. So more, if we have to consider normality for this kind of reaction, so molarity divided by 5 will give you the normality. In this case, molarity divided by 6 will give you the normality. Similar in this case, it will be divided by 1 only, because there is only one loss of electrons happens in this case. Similar in the precipitation reactions, so 1 mole of barium chloride precipitates to barium sulfate reacting with sodium sulfate, and a similar fashion 1 molar of silver nitrate converts to silver chloride and precipitates out. So it's a very simple precipitation reaction where 1 mole is reacts with 1 mole. Then so we'll look in some of the, so far we have learned from molarity, normality and mole concept. So how do you define moles or how do you calculate moles? Then we will try to understand more about mole concept by solving some of the questions which will help us in realizing the concept much clearer and where it is used for. So let's look at the one example. How many moles of sodium chloride are present in 500 ml of 2 ml sodium chloride? So let me have my and then we can go from there. So we have, say, how many moles we're asking. Sorry, right. So we have the question is, let's begin again. How many moles of sodium chloride are present in 500 ml of 2 molar sodium chloride? So basically we want to know number of moles is present in this solution, and we have two informations. We have volume, and that is 500 ml, that is 0.5 liter, and our molarity which can represent by m. is 2. We can write it. Now the equations which is we are going to use in most of the cases, molarity is number of moles over volume in liter. There is one more equation we are going to use. What is number of moles? That is mass, which is expressed in gram, over molar mass. So mass is amount which you have weighed, and molar mass is 1 mole of that substance, how much it will weigh. So that is give the molar mass. So so how do we? So let's write the let's solve the molarity is how much we have 2 molar, right? And we want to know the number of moles, which we can write it as such, and which we have now is volume in liter, so which is 0.5 liter, right? And then we cross multiply this. Basically 2 is nothing but 2 over 1, so this will become number of moles equal to 2 multiplied by 0.5. Okay, so this side of this and this side of this will multiply, and they will cross multiply, and they will give you 2 into 0.5, that is they will give you 1 mole. So number of mole is 1. Now let's look at the next questions. What is the molarity of a solution containing 10 gram of potassium hydroxide? So what is the information we have? We have mass, we have mass which is 10 gram, we have volume which is 250 ml, and what do you want to know? Molarity. What is molarity? So molarity is nothing but number of moles, which I am going to represent by N over volume in liter. Now number of moles is nothing but mass over molar mass over volume in liter. This is what we have. Now you know what is the mass now? 10 gram. What is the molar mass? 56 gram. And what is the volume? Which is 250 ml. That means 0.25 liter. We can express like that. So this will become 10 over 56 multiplied by 0.25. We can simplify this. We can remove this point and we can multiply by 100. And this will become 15 4 the 100. Come 40 over 56. Then we have 10 4 10 the. So it will become 4. Sorry. So it will become 4 10 the, and then we have 14. So it will become 5 over 7, and ultimately it will give you 0.712 molar. So we can do the maths thereafter. Okay, and then this is about what we want to know. We wanted to know the molarity of the solution. So molarity of the solution we can calculate with volume is given and the amount which you have taken to make the solution. Okay, so so this is second questions. Now we'll move to the third questions. So how many grams of HCl are needed to prepare 100 ml of 1 molar HCl? So in the previous question we have a gram given, and we have given the volume, and we needed to know what is the molarity strength. Now we have to calculate how much grams of HCl are needed, and the volume is given. So basically what is given is volume, that is 0.1 liter, that is 100 ml we can say, and then we have molarity, we have given 1 molar. So we know what is the molarity is number of moles, which can represent by N, and volumes in liter we can represent. So if we calculate number of moles, we can calculate amount, because we know 1 molar mass is how much. So what is the molarity here? We have 1 molar solutions N over 0.1 liter. So number of moles which we have is 0.1. Now what is number of moles? So we need mass in gram over molar mass. Molar mass. So we know what is number of moles, 0.1. Mass we need to calculate, and molar mass is how much, of 36.5 gram. So if we cross multiply this is basically nothing but 0.1. So this will give you mass 3.65. Okay, 36.5 multiplied by 0.1, so one decimal it will change, so it will become 3.65 gram. So this much gram of hydrochloric acid is needed to make the 1 molar HCl of 100 ml. Now look at the fourth question. So you have to calculate the molarity of the 5 gram of glucose dissolved in 100 ml of water. So here what is given? Mass is given. How much mass is used? 5 gram. How much volume is made? 100 ml. Okay. Now we have to calculate the molarity. So molarity can be calculated as number of moles over volume in liter. Right, but we don't have number of moles, only we have amount. So molarity is, what is number of moles? We know that mass over molar mass, and we can volume in liter. So you, this we can put it like this. Okay. So now let's fill in the information. So what is the mass we have taken? 5 gram. What is the molar mass? It is given 180 gram. 1 mole is 180 gram over volume in liter, which is nothing but 0.1 liter. So we can have 5 over 180 multiplied by 0.1. Basically we will have 5 over 18. That's it. How much it will go? If we divide 5 divided by 18, it will be 2.78 molar. So this is the molarity of the solution. Will become, if we dissolve 5 gram of glucose in 100 ml of solution. Now move to the fifth question. So what is the molarity of, so this is the repetition. I'm to the sixth question. I probably missed the fifth question. Well, so if you have 250 ml of 4 molar sodium hydroxide, how many grams of sodium hydroxide does it contain? So we have two informations, right? We have molarity, that is 4. We have volume, which is 0.25 liter, and what do you want to know? Mass, how much amount is needed. So we'll go by the rule, mass over molarity over, molarity is number of moles over volume in liter. So we can calculate number of moles. So we, how much is the molarity? 4. Now number of moles we need to know, and the volume is 0.25. So what will have? We have number of moles, which will give you 1 mole. 1 mole will, sorry, not 1 molar, but 1 mole. Now what is the weight of 1 mole? 40 gram. So our answer will be 40 gram. So 40 gram of sodium hydroxide is needed to make. So 40 gram of sodium hydroxide is there in 250 ml of solution of 4 molar strength sodium hydroxide. Now move to the seventh question. How much water must be added to 100 ml of hydrochloric acid to make it 1 molar solution? So this is a mass balance equation kind of, or equivalence, molarity equivalence equation. So we have to use a formula here, which is mentioned. I have to mention M1 V1 is equal to M2 V2, where M is molarity, V is the volume of one solution, and M is the molarity of second solution, second thing, and volume of the second thing. So how we are going to consider that? So we have what we have. We have 100 ml of 6 molar HCl. Now we want to make 1 molar into volume will be how much? Okay. So how much water is added to make, added to 100 ml of 6 molar HCl to make it. So a total of 100 ml will be of 6 molar will make it to 100 ml. So we have done that. So volume, so V2 will be 600 ml. So this is, so the volume will be 600 ml. That will be the total volume we have to make it. So in the 100 ml of HCl will be taken in a beaker, and we will add water to make it 600 ml. So become, see, 1 molar HCl will become of 600 volume. So this will be the answer. So how much how much water will be added? 500 ml of water will be added. This much water we have to add it. They are asking how much water you need to add it to make it 1 molar of solution from 6 molar of HCl of 100 ml amount. Next question is, what volume of 2 molar HCl is needed to prepare 250 ml of 3 molar HCl? So here we have a 250 ml of 3 molar HCl. Uh, sorry, we have 12 molar HCl solution. Okay, from there we are going to make 250 ml of 3 molar HCl. So how much of this 12 molar of HCl is needed? So we have to use same formula, M1 V1 is equal to, sorry, M1 V1 is equal to M2 V2, right? So here what we have is 12 molar solution. Volume we have to calculate, and how much we have to make? 250 ml, that is 250 ml, and molarity is 3 molar, so multiply by 3. So basically we can 3 divided by 4, so volume become 250 by 4, so it will become 62.5 ml if we divide it. So this is 50, this is nothing but, sorry, 250 divided by 4. We can simplify more. This is 2, this is 125, and when you divide it, it will give you 62.5 ml. So this is what we'll have. So this much of volume is needed of 12 molar HCl to prepare 250 ml of 3 molar HCl. Rest will be, water will be added to make it to 250 ml. Then I will move to the next question. Okay, so we have how many ml of 0.5 molar sodium hydroxide are needed to neutralize 25 ml of 0.25 molar HCl? So if you look at the sodium hydroxide plus HCl reaction, we'll see कि 1 molar sodium hydroxide reacts with 1 molar of HCl. So they react in 1:1 molar ratio. So this is very easy. That makes our job very easy. What we have is 25 ml of 0.25 molar HCl. So number of moles in this will be how much? Let's calculate number of moles. So number of moles will be how much? 0.25 molar into 25 ml, or it could be 0.025. So this much of moles it will have. Okay, right. So this can also be, sorry, this could also be done by the mass balance reaction. So here say M1 V1 is equal to M2 V2. So what is M1? That is 0.25 multiplied by 25 ml is equal to, what is the molarity of sodium hydroxide? 0.5 molar multiplied by V2. So need to know the V2. So basically it will become 0.25 into 25 is equal to 0.5 V2. We can simplify as 25 into 25 into 50. So we 25 to the 50, then 25 over 2 it will become 12.5 ml. So this much ml of 0.5 molar sodium oxide needed to neutralize 25 ml of 0.25 molar HCl. This problem will be straightforward if the molarity of sodium hydroxide would have been same as point same as HCl. If it would have 0.25 molar of sodium oxide, we would have required 25 molar 25 ml only. So move to the next question, which is based on precipitation. How many moles of silver chloride will precipitate when 50 ml of 0.1 molar silver nitrate reacts with excess sodium chloride? So if we look at the equations, okay, so we see 1 mole of silver nitrate reacts with 1 mole of sodium chloride to make 1 mole of silver chloride. So here sodium chloride is in excess, so we can consider the all of the silver nitrate will be converted into silver chloride. So there is no question. So number of moles whichever is there in silver nitrate, same number of moles will be of silver chloride. So this is very straightforward questions. So we can just say what is number of moles. What is? Let me have my pen and so we know what is molarity. It is number of moles over volume in liter, right? So number of moles could be molarity into volume, volume in liter. So what is the molarity? 0.1 molar. What is the volume? 0.05. So I'll give you 0.0005 mole. This is the mole of silver chloride will be formed when silver nitrate reacts with sodium chloride. Now look at the 11th question. This is very common for the phosphate buffer preparations, which is we do in the lab very frequently. So how many grams of sodium dihydrogen phosphate are needed to make 1 liter of 0.2 molar buffer? So what we have is molarity, which is 0.2. We have volume, which is 1 liter. So we need to know amount of sodium dihydrogen phosphate. So for that purpose, we just need to calculate number of moles first. So let's do it. So molarity is nothing but number of moles over volume in liter. So what is the molarity here? 0.2 over number of moles. I can represent it by just n, and then volume in liter. So this will give you n is equal to 0.2 into volume in liter. What is liter? It is 1 liter. So 0.2 moles is there. Now what is the weight of, so what is number of mole? If we represent n number of moles, mass over molar mass, right? So 0.2 is equal to mass. What is the molar mass of sodium dihydrogen phosphate? So that is 120 gram. So mass will be 24 gram. So this much amount of sodium dihydrogen phosphate will be needed to make 1 liter of 0.2 molar buffer of phosphate. Now this is the last question. So we need 500 ml of 0.1 molar calcium chloride for media. How many grams of calcium chloride dihydrated are required? So here again the molarity is given, that is 0.1 molar. Volume is given, that is 0.5 liter, right? And how much amount is needed? So calcium chloride dihydrate is when you make calcium chloride, some of the water molecule get trapped. So you have to consider that water molecule which has comes from the substance. So that is the part of the molar mass. So if we calculate number of moles, we can calculate the mass required to make that solution. So let's do the equation. Write the equations. Mass is equal to number of moles over volume in liter. So basically number of moles is mass into volume. So we will have 0.1 multiplied by 0.1 multiplied by 0.5, that will be 0.05. This will be the number of moles which will have. And if you multiply this by 147 molar mass, we'll get the value 7.35. Okay, it's I was doing in a one way, so I'll do it the same way. Let's do it. So this is the one. So we have number of moles is equal to mass in gram over molar mass. So number of moles is 0.05, right? Now mass we need to know, which is not known, and molar mass is 147, and this is means that over 1. So we can cross multiply and it will become mass over mass is equal to 147 into 0.05. Sorry, this is point, sorry, 0.05. So this is 7.35 gram. So this much of calcium chloride will be needed to make 0.1 molar of calcium chloride 500 ml volume. Okay, so whenever you make solutions, you have to measure the amount that you need it, say 10 gram, 20 gram, and you add some water and dissolve it completely, kind of. So 80% of that volume which you have calculated, you have to add it. uh, Say if you are making 1 liter, so 800 ml of water will be needed, and then dissolve it completely, then you make up the volume to 100 ml. That is how 100 liter, sorry, 1 liter, and that is how you make a solution. Okay, this is the right way, but you do the calculation this way, so that we have learned it how to make uh, any molar solutions, given provided we have been told what is the strength and how much volume do we need it. Or even if we have given some solution, and if there is the molarity is given, volume is given, how many moles are there in that. So, and say for example, if I have given 100 ml of 0.1 molar of sodium chloride, if you take 10 ml of that, of 0.1 molar sodium chloride, how much moles you have taken, that also you can calculation, you can do it. So those kind of questions can be asked, but once you get this hang of it, this calculation, this mole concepts, it'll be very easy to do it. Okay, and then so I'll just summarize this, uh, what we have learned so far. Okay, so what we have learned is, we have learned what is mole. So mole is a able to measure the quantity which are very small in size, like atoms, molecules, electron, ions, and it gives us idea to have a um, uh, gives us idea to measure the quantity which is very small. So 1 mole equals to 6.02 into 6.02 into 10 to the power 23 particles. Okay, so basically mole is also moles. So how mole is defined? So mole, sorry, so mole is nothing but mass in gram over molar mass. Okay, molar mass, which is gram per mole, and 1 mole is 1 mole is nothing but 6.022 into 10 power 23 particles. That is called Avogadro number. So if you take 1 mole of sodium chloride or 1 mole of potassium chloride, will have same number of particles in it. Okay, and then we also learned molarity. Molarity is nothing but number of moles over volume, which is represented in liter. Okay, this will give you the molarity. And we also learned normality, that gives you number of equivalence over volume in liter. Now say I have 1 molar sulfuric acid. So what could be the normality? Okay, so its normality will be different from the molarity because it has a number of equivalents. It has two hydros H plus ions will be secret. So it will have two normal solutions if we take 1 mole of sulfuric acid because two H plus ions will be given by it. Okay, so and we so any problem which we need, we also have learned um, m1 mass of 1 into volume of 1 is equal to mass of 2 into volume of 2. Well, sorry, mass nahi, molarity of 1 into volume of 1 of molarity of second and volume of 2. So if we have some mass of 1, sorry, molarity of 1 and the volume of 1, and if we know what is the molarity of second, we can know what is the volume which we can make it from there, right? So these are the some 3-4 equations which we learned it, and we'll discuss more questions and more complex questions and more day-to-day uh, life or the, what do you say, chemistry lab problems, or even in the biotech lab, what you do it, what kind of solution make it, how do you make it. So those kind of calculations we'll discuss in very next chapter. तो सभी को ध्यान खींचने के लिए और ध्यान देने के लिए आपका बहुत बहुत धन्यवाद. थैंक्स अ लॉट. विल कैच अप विद द नेक्स्ट लेक्चर. थैंक्स अ लॉट.